Hi everyone, it's Becky. We're going to be reading section 7.1 and 7.2, which is our introduction to trigonometry. And I wanted to start by acknowledging that trig is one of the hardest subjects that we're going to tackle this semester. And we're doing it now at the beginning of the semester on purpose, right? So we used to teach it, we used to get to this hardest material at the end of the semester when everyone was exhausted and had no more headspace for new ideas. And so what we're doing now is we've moved it to the beginning of the semester. And we do something called a spiral pedagogy, where it comes up and it hits something again and again and again, right? So we're going to work on it now. This is our introduction, and then we'll come back to it again later in the semester after we've had some time for it to, like, these ideas to sink in, and then we'll come back to them to work on them and dig a little deeper. So in 7.1 and 7.2, we get an introduction to trig. Why would we want to study this thing if it's so hard? So trig functions are really, really, really important. Let's just write that down. Trig functions are really important. Why? They're important because they're cyclical, they're periodic, they repeat over and over and over again. It's possible you've already seen, even before reading, a graph that looks like this, right? It just goes up and down and up and down and up and down and up and down. And so something like this looks, it's not very well drawn, but it looks like a sine function. And so you can, even looking at this graph, you can see right away, right? We're going to use these things to study waves, sound waves, and light waves, right? So applications, sound waves, light waves, but really anything that repeats itself. So something like tides, or heartbeat, or breathing, right? Anything at all that just repeats itself with regularity. It doesn't have to look nice and smooth like that sine function, but we can combine the different trig functions to get a model of something that's repeating like this. And so these are just hugely, hugely, hugely important applications. They're also pretty beautiful in their own right. In these sections, 7.1 and 7.2, we're going to go back to some of the basics and build our way up to these trig functions and these beautiful waves. And so in section 7.1, we're going to be learning about angles, right? In 7.2, we'll be learning about right angle trigonometry. We'll talk a little bit about that. One of the things that we often struggle with in section 7.1 is radian measure. So we're going to be learning about angles. Oops. Sometimes it's a bit of a trick. So angles. In the American education system, at least, I'm not sure exactly about other countries, we're usually taught angles in degrees, and so that's usually what we're most familiar with. So we have degree measure. But we really want you to push yourself to convert to thinking about angles in radian measure. And if you've seen it before, you might be uncomfortable or less comfortable with radian measure. It involves pi, which doesn't have this nice full numbers that we're used to in degree measure. But we're going to challenge you to switch over to radian measure. Actually, in Math 5a and in 10a in calculus, we'll actually require you to be using radian measure. It's not an arbitrary decision on our part. In fact, degree measure is pretty arbitrary. People chose it because it happened to be a little bit convenient. But radian measure actually has meaning. And so that's what we tend to use in math and in sciences, because we like our things to have meaning and not to be just something we have to memorize. And so what is this meaning of radian measure? Well, I argue that actually you already are a little bit familiar with it, even if you don't know it. And so if you recall, the formula for the circumference of a circle, to remember, is 2 pi, right, times the radius r, right? And remember, pi is just a number, and I shouldn't say just because it's a really important number. It's 3.14159 something, 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 right? It's just a number. And so what is the circumference of a circle, right? The circumference is the measure of that length around the circle, right? So circumference is measure of length around the circle. And so what's happening here? So it depends on the radius, right? So I'm going to try to draw a circle. I don't usually do a very good job. It's usually easy. Oh, my iPad just made it into a real circle. I wonder if it'll pop my axes into place too? Probably not, right? So here are my axes, X and Y. And I'm gonna declare this to be a circle of radius 1. So the radius is 1, which means this distance from the origin out on the x-axis is 1, out on the y-axis is 1. You get -1 in the negative direction on the x-axis, -1 in the negative direction on the y-axis. It's a circle of radius 1. And now let's say this is a circle of radius 1 mile, right? And I'm walking around the circle. And so what that says is for a circle of radius 1, radius r equals 1, the circumference is 2 pi times the radius, which is 1, which is 2 pi. And pi is 3.14, et cetera, et cetera. So this is about 2 times 3.14, which is 6.28, right? And so if this is a circle of radius 1, and I walked around that circle, right, like this, all the way around the circle, I would be walking, if I walk one time around the circle, I'd be walking a distance of about 6.28 miles. Or kilometers if you're not from the US, right? And so the radian measure is a measure of the angles that's related to the distance that you're walking around the circle, okay? And so the radian measure of an angle theta, radian measure of an angle, we often use these Greek letters. Theta is our favorite one for angles, right? So the radian measure of an angle theta is equal to the distance traveled on a circle. I'll say of radius 1. So you can change the radius of your circle, but then you have to divide by the radius for the angle. The distance traveled on a circle of radius 1 corresponding to that angle, to the angle theta. So when I say corresponding to the angle theta, I'm sort of sweeping some technical definition in the language under the rug because it gets a little bit hard to say and then hard to understand. So when I say corresponding to the angle theta, I mean we have to put our angle theta in the right position, first of all, which we're going to learn is called standard position. So it has to start on the positive x-axis and go out counterclockwise from there. Or, well, actually for this, it doesn't have to go counterclockwise, but for standard position it does. So we're going to start here, and we're going to rotate by some theta, angle theta. Okay, and when I say corresponding to the angle theta, I mean how far am I walking on the circle of radius 1, right, to sort of hit that end point, we call it the terminal side of that angle, right? And so if I have an angle of 2 pi, I walk that full 6.28 miles. If I have an angle of pi, right, I'm going halfway around the circle, I walk a distance of 3.14 miles. If I have an angle of pi over 2, right, I'm walking half of 3.14, about 1.5, or more than 1.5 miles, right? If I have a theta, an angle of 1, no pi's, just the number 1, I've walked 1 mile along the circle, right? So that's how this radian measure works. It's something that you really have to like go over and over and over and over again in your head in order to really let it solidify in your head. And you'll think, oh, I got it. And then a little while later, you're like, oh, I don't get it anymore. You have to start over again. That's okay. That's normal. It's part of the education process. And that's true for a lot of these things with the trig. It's so abstract. You have to keep going through this thing again and again and again. Okay, so we're going to work, right? Our challenge is to convert ourselves over into thinking in terms of radian measure. In section 7.2, you're going to learn about right angle trigonometry. If you've studied trig before, this is probably the most familiar part to you. It's pretty straightforward once you get a chance to play around with it a little bit and practice. And so these are right angle trigonometry, and so you're looking at right triangles, which means that it has an angle of 90 degrees, which we indicate with a little box like this. And you want to study an angle theta, we often put it in one of these other corners. My internet seems to be slow and not catching up with me. Oop, there we go. And then in a right triangle, this side length of the triangle that is across from the right angle, we call the hypotenuse, which I've shortened HRP. Okay, and then the other side lengths of the triangle we label relative to the angle. So we're going to call this vertical side the opposite side because it's opposite of the angle theta that we're interested in. And this side here adjacent because it's adjacent to the angle theta that we're in. And then we're going to define these trig ratios, sine, cosine, and tangent, so TOA, using this little mnemonic device. So this says that sine of the angle theta is opposite over hypotenuse. This part says cosine of the angle theta is the adjacent divided by the hypotenuse. And this part says that tangent of that same angle theta is the opposite, oops, I've written it down wrong, opposite, so TOA, divided by the adjacent. Okay, and so these three basic trig functions that we're working with, sine, cosine, and tangent, they're trig ratios. They're ratios of lengths. Okay, and in particular, what that's going to mean is that if you have similar triangles, you take that same triangle and you make it bigger or smaller, but with the same angles, the sine and the cosine and the tangent are not going to change. The ratios of those lengths are going to stay the same when you zoom in or zoom out. Okay, and then one thing I want us to be careful about is that if we label this other angle up here, phi, with a different Greek letter, we still use these same definitions, but now for the purple phi, this side is going to be the opposite side relative to phi, and this side is the adjacent side, right? So we have the same exact definitions, but the adjacent is relative to where the angle is. It's the adjacent is attached to the angle, right? And opposite is opposite from the angle. Okay, so you're going to go through, try to read sections 7.1 and 7.2. If you don't understand all of it right away, that's totally normal. Do your best. We're going to work on this stuff together in class. Then we're going to come back and read 7.3 and 7.4, work on it again in class. You're probably going to have to go back and read it again, try a lot of examples, practice. It'll start to sink in, and then when we come back again at the end of the semester to touch on this stuff again, you'll have a lot of these pieces in place already, and then you'll be able to, your mind will be ready to dig in deeper. So I'm really excited to start this trig journey with you, and I hope you enjoy it.